Max, consciousness is one of the great conundrums of science, indeed of philosophy, and there are many different theories about what it is. One of the theories, one class of theories, tries to call on quantum mechanics, quantum physics, as a way of explaining it because of the huge number of computational opportunities that quantum physics would give us that classical physics would not. You've been a critic of applying quantum physics in consciousness. Why?
I've been a reluctant critic of the idea that consciousness is a quantum computation, because I think quantum computers are a wonderful idea, and I would have loved to brag to my friends that I had a quantum computer here on my shoulders. But it turns out that quantum computers only work if they can keep their information secret from the rest of the world. And I once calculated, supposing that the computations have something to do with the firing of neurons, which most people think, how long can they keep a secret? How long can a neuron be both firing and not firing in a quantum superposition without the rest of the world finding out? 10 to the minus 20 seconds, it turns out. It's way less time than you need to complete any kind of thought, which means that if our neurons have anything to do with consciousness, sorry, it's the classical computer.
Yeah, because neurons fire in the kilohertz. It's one every millisecond would be the maximum that it could do. So if it was totally firing, it could do a theoretical maximum of say 1,000 a second. It could never even do that many.
That's right. And then Roger Penrose and Stuart Hameroff and others have been proposing that maybe it's not the neurons, maybe it's microtubules inside the neurons that do it, and they've argued that maybe the decoherence time on the time scale on which the secrets leak out there could be brought down to be as long as maybe a 10,000th of a second, but that's still not long enough to have long thoughts. And the arguments they have for getting things to last even longer, I'm honestly not persuaded by at all at this stage. And that also doesn't explain in any way how different neurons in different parts of the brain are supposed to communicate with each other without the secret getting out. It would be wonderful if you can discover a new way of doing, quantum computation using microtubules. If it's correct, then ultimately these guys will be multimillionaires by patenting their ideas. But I'm not gonna bet my money on it.
If we look at even the theoretical idea of a quantum consciousness, you either have to assume that the quantum events are being translated into the firing of the neuron, and that's the currency of conscious information, or you have to make some assumption that the neuronal firings are not the totality. There's some sort of a superposition of neurons and quantum states that is occurring in a non-neural sense. It's frankly hard for me to understand how either one can lead to a greater information.
I agree, and this is why I view this as a pretty unlikely scenario. I think also, honestly, even though proponents of quantum consciousness don't say this, there's also an emotional element in there that people feel that quantum mechanics is a mystery and consciousness is a mystery, so they must be related.
Yeah, especially because in quantum mechanics, in some versions of it, you need the observer to participate to make quantum mechanics work. And so maybe in reverse, there's some symmetry there.
Precisely.
I mean, I can sort of, on some nights feel that makes sense.
And in fairness, physicists have been arguing now for about 100 years about whether this Schrödinger equation that describes what happens in the future actually has a little footnote to it saying that sometimes it doesn't hold and the wave function collapses, which is where some people try to say consciousness causes this. And then other people, to which I belong, who say, no, this equation always applies, no ifs or buts. That also leads to something some people find unpalatable, and leads to the prediction that actually sometimes reality, in a certain sense, splits out, as I talk a lot about in my book, into several different parallel branches. So if you get a parking ticket, there's another branch where you didn't, and so on. And what's so awesome about this is not the philosophical debate that's going to go on forever, because there are experiments being attempted now to build these vast quantum computers, which will fail if the wave function collapses, and they will succeed if I'm right and it doesn't collapse. And they will succeed to calculate things very rapidly that would take more than the age of our universe, precisely by, in a sense, tapping into the computational power of these parallel universes. So if we get these quantum computers going in the future, I think more people will come around to saying, well, seems reasonable.
But these are two radically different views. For if quantum mechanics demands the observer to be involved in the collapse of the wave function, if consciousness is critical, then maybe in some symmetrical way, quantum mechanics and consciousness are more related. On the other hand, if consciousness is not required in quantum mechanics, and if you explore every facet of the Schrödinger equation so that all these multiple worlds are real, that seems like an equally, if not more, fantastic result.
Reality is fantastic. It's turned out to be vastly more fantastic than we thought. But even though it's fantastic in its grandeur, it's actually an extremely simple and elegant description of what's going on. And it also makes these very testable predictions, which we will test when we try to build quantum computers.